Hello everyone, I am Maithri. I am the student of second year MSc at Manasa Gangotri College, Department of Computer Science. I am going to explain Decision Tree Classifier. These are the contents which are included in my presentation. Definitions of decision tree and its structure, introductions of decision tree classifier, explanations with an examples of decision tree terminologies, and algorithm of the decision tree, approaches of the attribute selection measures, information gain and Gini index with examples. Definition of decision tree. Decision tree is a supervised learning technology that can be used for both classification and regression problems, but mostly preferred is classification problems. It's a tree structure classifier where internal node represents the features of the dataset, branches represents the decision rules, and each leaf node represents the outcome. In decision tree, there are two nodes, which are decision node and the leaf node. Decision node are used to make any decisions and have a multiple branches, whereas leaf nodes are the output of those decisions and do not contain any further branches. Decision tree or the test are performed on the basis of the features of the given dataset. It's a graphical representation for getting all the possible solution to a problem or decisions based on the given conditions. It's called a decision tree because it's similar to a tree. It starts with a root node which expands on further branches and constructs a tree-like structure. In order to build a tree, we use a CART algorithm, which stands for Classification and Regression Tree Algorithm. A decision tree simply asks a questions, and based on the answer yes or no, it further splits into tree subtree. This is a diagrammatic representation how to construct a decision tree. Decision tree classifier. There are various algorithms to machine learning, so choosing the best algorithm for the given dataset and the problem is the main point to remember while creating a machine learning model. Below are the two reasons for using the decision tree. Decision tree usually mimic human thinking ability while making a decision, so it is easy to understand. The logic behind the decision tree can be easily understood because it shows a tree-like structure. Decision tree terminologies. Root node. Root node is the form where the decision tree starts. It represents the entire data set, which further get divided into two or more homogeneous sets. Leaf node. Leaf node are the final output node and the tree cannot be segregated further after getting a leaf node. Splitting. Splitting is a process of dividing the decision node or root node into subnodes according to the given condition. Branches or subtree. The tree formed by splitting the tree is called branches or subtree. Pruning. Pruning is a process of removing unwanted branches from the tree. Parent or child node. The root node of the tree is called parent and other nodes are called child nodes. Let us see how does the decision tree algorithm works. In decision tree, for predicting the classes of the given dataset, the algorithm starts from root node of the tree. This algorithm compares the values of the root node with the record attribute and based on the comparison follows the branch and jump to the next node. For the next node, the algorithm again compares the attribute value with the other subnodes and move further. It continues the process until it reaches the leaf node of the tree. The complete process can better understand using the below algorithm. This is an algorithm for decision tree classifier. Step 1. Begin the tree with a root node says yes, which contains the complete data set. Find the best attribute in the data set using attribute selection measures. Step 3. Divide the S into subsets that contains possible values for the best attribute. Step 4. Generate the decision tree node which contains the best attribute. Step 5. Recursively make new decision trees using the subset of the dataset created in a step 3. Continue this process until a stage is reached where you can't further classify the nodes and call the final node as a leaf node. Let us see one example we can understand better way of how to construct the decision tree. Suppose there is a candidate who has job offer and want to decide whether he should accept the offer or not. So to solve this problem, the decision tree starts with the root node. The root node splits further into next decision node and one leaf node based on corresponding labels. The next decision node further gets splits into one decision node and one leaf node. Finally, the decision node splits into leaf node. Consider the below diagram. This gives better understand of the decision tree structure. Here, company provide salary between 50,000 to 80,000 and he will say yes, and office, and also thinking office is near to home or not, and it is available for him, so he will say yes, and uh, and also thinking the company will provide cab facilities, and he will say yes and accept the offer. And this is another example for decision tree classifier. Attribute selection measures. While implementing a decision tree, the main issue arises that how to select the best attributes for a root node and for a sub node. So to solve such a problem, there is a technique which is called attribute selection measures or ASM. By this measurement, we can select best attributes for the nodes of the tree. There are two popular techniques for ASM, which are information gain, Gini index. Information gain. Information gain is a measurement of changes in entropy after the segmentation of data set on an attribute. It calculates how much information a feature provides us about a class. According to the value of the information gain, we split the nodes and build a decision tree. A decision tree algorithm always tries to maximize the value of the information gain, and nodes or attributes having the highest information gain, and it will split first. It can be calculated using the below formula. Information gain is equal to entropy of S minus weighted average into entropy of each feature. What is entropy? Entropy is a metric to measure the impurity in a given attribute. It specifies the randomness in data. Entropy can be calculated as entropy of S is equal to minus probability of S log 2 probability of S minus probability of no log 2 probability of no, where S is equal to total number of samples. This tabulated data set defines the playing golf. It consisting of 5 attributes that are outlook, temperature, humidity, wind, and play. And inside it consisting of datas which are sunny, overcast, rainy, hot, mild, cold, high, normal, false, true, yes or no. And that tabular column will use it to better understanding how information gain will be calculated. Before going to information gain calculation, first we learn definitions of the Shannon entropy. This formula is helpful for calculations of information gain. Usually ID3 algorithm is used to build the decision trees. It uses entropy and information gain to build a tree. The h of x Shannon entropy of a discrete random variable x with the possible values x1, x2, x3, so on xn, and probability mass function p of x is defined as h of x is equal to minus sigma p of x log p of x. For a given example, playing golf, we get two outcomes. One is yes, another one is no. Yes consisting of probability of yes consists 9 yes and probability of no consists 5 no's out of 14. We just use the Shannon entropy formula to calculate the h of x values. H of playing golf is equal to h of 9 comma 5, that is equal to minus 0.464 log to 0.64 minus 0.36 log to 0.36. The value 0.64 is came by 9 by 14 and the value 0.36 is got by 5 by 14, and by calculating this we get Shannon entropy value 0.94. E of t comma x is equal to sigma p of x into E of x. This is a formula for calculating entropy. We have to calculate the entropy with respect to given predictor feature in order to able to calculate information gain. For probability of yes, we got 2 in Sunny. Probability of no is equal to 3 we got from Sunny. For overcast, we got probability of yes 4 and probability of no 0. For rainy, probability of yes we got 3, probability of no we got 2. Entropy of playing golf comma outlook is equal to probability of sunny E of 2 comma 3, probability of overcast E of 4 comma 0, and probability of rainy E of 3 comma 2. By calculating this, we get entropy of playing golf come outlook, we get 0.6936. Information gain is equal to h of play golf minus E of play golf comma outlook. By calculating the values, we get 0.247. This is information gain. For this example, we can further calculate information gain outlook, temperature, humidity and wind. Based on these values, we can construct the decision tree. And this is a final decision tree structure. Gini index. Gini index is a measure of impurity or purity used while creating a decision tree in the CART algorithm. An attribute with a low Gini index should be preferred as compared to the high Gini index. It only creates binary splits, and the CART algorithm uses the Gini index to create binary splits. Gini index can be calculated using below formula. Gini index is equal to 1 minus sigma j pj2. Pruning. Getting an optimal decision tree is called pruning. Pruning is a process of deleting the unnecessary nodes from the tree in order to get the optimal decision tree. A too large tree increases the risk of overfitting, and a small tree may not capture all the important features of the dataset. Therefore, a technique that decreases the size of the learning tree without reducing accuracy is known as pruning. There are two types of pruning technology we are used: cost complex pruning and reduced error pruning. Advantages of the decision tree. It is simple to understand as it follows the same process which a human follows while making a decision in a real life. It can be very useful for solving the decision related problems. It helps to think about all the possible outcomes for a problem. There is a less requirement of data cleaning compared to other algorithms. Disadvantage of the decision tree. The decision tree contains lot of layers which makes it complex. It may have overfitting issue which can be resolved using the random forest algorithm. For some class labels, the computational complexity of the decision tree may increase. These are the reference. This is end of my part. Thank you.